We're going to talk about linear quadratic systems again, but this time we're going to solve them by graphing. The problem with solving by graphing is your graphs have to be completely accurate, and our lines will be. Our quadratics, maybe not so much. So we'll see what we do in a second. So first, let's do the warm-ups, just a review of some things. Graph each function on a coordinate plane. So y equals 2 over 5x minus 3. So remember, that is y equals mx plus b, where b is our y-intercept. So in this case, our y-intercept is at 0, -3. So that's our starting point. Then from there, we need to use the slope to find our next point. So our slope is the m, 2 over 5. So that is 2 up and 5 to the right. We always go to the right because that's how we read, left to right. We're reading the graphs left to right. So up 2 to the right 5. So it's only 1 point though, or I guess 2 points total. So if we want another point, it is the same thing as saying 2 down and 5 left. Kind of like a double negative. So down 2 to the 5 left, and now we have a better linear function. And if I didn't draw it, it'd be very good. But we have our line. Nothing crazy going on there. Number 2, y equals x squared plus 6x plus 8. Well, we've solved these, or graphed these, by finding the zeros and the y-intercept. So, and the vertex. So let's find those. So first, let's find the zeros. If my stylus will work. There we go. The zeros are gotten. There's some number, comma 0, where y equals 0. So 0 equals x squared plus 6x plus 8. So we can factor this. We'll do our diamond problem. We want a product of 8, a sum of 6, so that would be 2 and 4. And because the coefficient of x squared is 1, we can skip right down to here, where we just use our diamond problem answers as a second part of each binomial, each set of parentheses. Then we set those equal to 0 and solve for x. So the first one, x equals -2, second one equals x equals -4. So those are our zeros. So really we need at least one more point. The y-intercept would be nice, except it's off the graph. The constant, remember what we did last semester, this 8 is the y-intercept, but that's about up there. So not really going to help us when we're trying to graph this. So what we're going to do is find the vertex. If I can get my stylus working again. So our vertex is in between our zeros. So the way we can get in between there is we take the average of those two values. -2 plus -4 divided by 2 to find the average. So it's -6 divided by 2. That's -3 is our h, or our vertex x. So to find our vertex y, we just substitute that into the equation. So y equals -3 squared plus 6 times -3 plus 8. Notice my -3's are inside parentheses so that we don't mess up with our negatives. All right, so y equals -3 squared is a positive 9. If you say it's a -9, you're lying, and I will not like that. 6 times -3, -18, and then plus 8. So when we add all those up, we get y is -1. So our vertex, so that is our k, or our vertex y coordinate. So it's -3, -1. So we can graph our vertex right here and connect the dots. Problem is, this is super accurate? No, because after those 2 points, we don't know exactly the angle that they take off at. So that's why graphing by hand to find these system solutions might not be the best way to go. So we're going to look at other ways to do that later on. So previously, we solved linear quadratic systems by elimination. Well, now we're going to look at graphing, and that really gets to the point of what's going on at those points. So if we want to solve the system y equals negative x squared plus 5 and y equals x plus 3, we graph both of them. But again, our graphs aren't perfect. So what we're going to see in a second is to use the calculator or a graph that's given to you. Now here, hopefully, this is pretty straightforward for you. That where they intersect, where the line, the red, intersects the blue, are those 2 points. And they're integer points, so they should be easy. So negative 2, 1 is one of our solutions, and our other solution is 1, 4. We didn't have to eliminate variables. We didn't have to do all this crazy stuff. It's just there. So if we were to solve this by substitution, we'd have our x values of 1 and negative 2. Then we'd substitute those in and get our y values. So if we're going to do this on a calculator, TI-84, so obviously we need to put our equations in our y equals. I put them in y1 and y2. Doesn't matter where you put them. But I turned off the other equations because I don't want to see anything else except for those two. So we have those two highlighted. You can see the equal signs are highlighted. So we are going to go to Zoom, and we're going to do number 6Z standard, just to reset our windows. Sometimes they could be left over from another problem, another class, another person, and you won't have any idea what's going on. So we'll just stick to standard. Should give us our graph. There is our parabola, looks nice. And there is our line. One thing we can do, if we hit second zoom for format, we can arrow down, and put the grid on, grid dot. You can actually put the grid lines on as well. Now, when we graph this, it kind of looks weird, but we should be able to tell a little bit better where our intersections are. So there are actually on integer points. This would be 1, 4, and negative 2, 1. And again, we already knew that. But quite honestly, I find that kind of just distracting. I don't like those dots, so I'm going to turn them back off again. Graph, gotta wait for it to graph again. So another way we can find these intersection points is going to what we did last semester a lot. Second, trace to our calculate menu, and then just number 5. So it says the first curve, all right, the quadratic, second curve, not really a curve, it's a line, but that's what they're talking about. And then a guess, and I'm gonna go somewhere over where it is, only because there's 2 of them, and we gotta separate the 2 of them. All right, so their intersection is at 1, 4. We knew that. So second, trace yet again for number 5. So first curve, we are on the blue, looks up here, so that's fine. Now we're on the red, that's fine. But now our guess, well, we want to go farther to the left because we know our solution's down there somewhere. So we'll make that as the guess. And then we can find our other intersection of negative 2, 1. It's as simple as that is. No calculations are necessary. Use the tools on the calculator and or just look at the graphs. So that's what we're doing with graphing. Very straightforward, very simple. So these ones kind of got cut off, so we're just going to travel to these. They want to know the solutions. Well, it's pretty easy. They don't give us the equation, so we couldn't do it any other way. However, it's, again, pretty straightforward. There's one intersection, so that is at 0, negative 1. And then we got another one down here, and that's at negative 5, negative 6. And there are solutions, done. That's as much as we have to do. On the next one, it's kind of faint, but we have one there and one intersection there. So that would be at 1, 8, numbers are kind of hard to read, and 4, 5. And that's it. So if you have a graphing calculator, you can do that on a graphing calculator so much quicker than doing it by hand. So let's try one last one. We have the intersection points graphed and labeled, so we should be able to figure out what they are, but let's use our calculator to do this, just to double check. Go to the y equals. I'm going to unhighlight these two equal signs and do these two equal signs, because I need those two equations. So we graph it. We could put on the grid again, but I don't really like it, quite honestly. I just want to look at where our intersections are using the calculate menu. So second trace. So we want 5 intersection. First curve, the black parabola. Second curve, the pink line. And, well, there's somewhere right here. So we don't need to take a guess yet. We could just hit enter. And since it was right there, we got it. So 1, 3. And, of course, if we look at it, that is 1, 3. Not rocket science. Find our other one. Whoop. And this is useful even if our answers aren't integers. Even if they're super nasty, we can find it this way. So second, calculate. Go to our intersect. First curve, the black parabola. Second curve, the pink line. And then we need to take a guess. Well, we know the x value is over here somewhere. So let me just type in -3, hit enter, and it takes us to our other one. -3 obviously was not our solution, but -3 took us real close to this intersection, so it found this one instead of the other intersection that we found. So -4, -2. And again, you can just look at this graph and see it. But the calculator is nice if we don't have integer answers. As long as they're real numbers, we can find it fairly easily. And that's graphing systems.